Okay, yesterday we discussed about UVM factory. So why we need that UVM factory? Without changing the test bench code, we can able to override a particular type with another type, okay, during the runtime. So that override we have to mention in the test. So for that we need to register the components and object to the factory by using the UVM component utils and the UVM object utils. Then if you register that to a factory, you have to use create method to create an object for a component or a object. So now we are going to see about UVM phases. So it is very important in UVM. So clearly in Verilog and VHDL, a static elaboration of instance occurred before simulation starts. In Verilog test bench, you see while we do the simulation, before that we have to compile. Okay, we have to compile the code, and by giving elaboration command, we have to elaborate. That means we have to make sure that all connections are happen between the hierarchy. Then we will do the simulation. But in system where classes are instantiated at runtime. Okay, so there is no guarantee that before sending the transaction or a data, the connections are happened properly. So there's a chance for miss the transactions. So this problem is overcome by UVM phases in UVM. So here you have these phases like build, connect, end of collaboration, start of simulation, run, extract, check, report, and final. These are the UVM phases available. This will be executed in this order only, so that we can make sure that first every components are built, okay, and then after building the component, the connections are made between the component or between the TLM ports. And the end of elaboration, we can able to display by using display. We can able to print the structure, whether it is connected or not. That we can check here. Then start of simulation. If you want to make any predefined conditions or configuration, if you want to do before the run, so we can use of this start of simulation phase. Then run phase is the actual phase where the process happens. So simulation happens here in the run phase. Then extract phase, here we can able to get the output from the DUT. Okay, extract phase, you can able to get the values, and in check phase, you can compare the expected value with the actual value, and the report phase, you can use the report whether the test case is pass or fail. So final phase, if you want to display anything before the end of the simulation, you can mention in the final phase. So this UVM phases generally classified as a build phase, so run phase, and this is post run. Okay. Pre-run phase, we have the build phase. These phases are called pre-run. Build, connect, end of collaboration, start of simulation are called pre-run phase, and this extract, check, report, final are called post-run phase. Okay. So here these phases, pre-run phases, will not consume any time. Okay, at 0 time, everything will happen. Okay. This run phase is the actual runtime of the process. Okay. So this post-run phase also consuming 0 time, so that you can able to tell which are all the phases are task and which are all the phases are function. Okay. You know, right? Difference between function and task. So function consume 0 time. At 0 simulation time, that will happen. So So these are the phases implemented by the function. Okay. So this run phase is implemented by task. So generally we can classify pre-run, that is build phase, this run phase, then clean phase, that is post-run. So in pre-run or build phase, we have build phase, connect phase, end of elaboration, start of simulation phase. So these are functions. Expect this run task. Okay, remaining all are functions. Okay. So in build phase, what we are doing is to build the test bench components and create the instance. Then connect phase used to connect the between different test bench components via TLM ports connection we are doing. Then end of elaboration phase is to display the UVM topology, another function required to be done after connection. Then start of simulation phase is to set initial runtime configuration or display the topology. Then run phase is the actual phase, actual simulation that consume time happens in UVM phase and run parallel to other run phases. If you mention run phase in more than one components, okay, so all the run phases happens parallelly at the same time. Then extract phase. So these are all functions used to extract and compute the expected data from the scoreboard. And check phase, it is used to perform a scoreboard task to check for error between the expected value and actual value. Then report phase is used to display the result from the checker whether the test phase is pass or fail. Then final phase typically used to last minute operation before exit the simulation. So it is not compulsory you should use all the phases. Okay. So generally we will use this build phase to create the components and connect phase to make the connection between the components and TLM ports, and run phase, important phase we are using. Then in scoreboard we may use this check phase or extract phase. Then these phases except this run phase and build phase, actually these phases, okay, these build phase, connect phase, end of elaboration, all these phases are extract from, that is inherited from this UVM bottom up phase. It is inherited from UVM phase. UVM phase is there. So this UVM phase is inherited from UVM object. So UVM object is inherited from UVM void. Okay. So early classes we discussed, right? It's simple hierarchy structure. So top level is UVM void. From that we are inheriting UVM object. So from that you are inheriting UVM phase. So from that you are inheriting UVM bottom up phase. Okay. So here except this run phase and then build phase, remaining all phases are inherited from UVM bottom up phase. Okay. Then build phase is inherited from UVM top down phase. So that means in build phase you have to create the top level. It is why it is bottom down means. So first you have to create the environment. Okay, inside the environment you have to create the agent. So inside the agent you have to build sequencer, driver and monitor. Okay, so it is happening in top down. Then remaining phase, if you see connect phase, first you have to make the connection between sequencer and driver. Then you have to make connection between scoreboard and monitor. So the remaining every phase will happen from bottom to top. Okay. Bottom up phase. So run phase, it is extracted or inherited from UVM task phase. Okay. It is inherited from UVM phases. Then run phase is subdivided into reset phase, configure phase, main phase and shutdown phase. Okay. If you want, you can explicitly mention these phases. Okay. So inside the run phase, you can mention reset phase and you can perform the reset operation. So configure phase, so function void configure phase, you can write the configuration steps. Okay. So in the same way, main phase, shutdown phases are there. So again, it is classified into two functions: pre-reset and post-reset. Pre-configuration, post-configuration, pre-main and post-main, pre-setup and post-setup. So these are the sub phases available in run phase. So if you want, you can use this phase by explicitly mention the phases inside the run phase. Then one more thing is, so this run phase, actually run phase is only the time consuming one. Okay. So this run phase end, if the time expires before all the objections are dropped, the default timeout is set as 9200 seconds. Okay. So how long this run phase will happen? Defaultly, it happens for 9200 seconds. Okay. So before we drop all the objections. Okay. So that means I will explain the objection in after two more slides. Okay. So if we didn't drop the objection also, this run phase will happen up to this much seconds only. So if you want to override this default seconds, you can use this set timeout. Okay. Set timeout is the function available. So you can call this set timeout. Okay. Phase dot set timeout. You can pass the value for the time. So I want to increase my default timeout. Okay. So I can mention like this: phase dot set timeout. So here I can increase my time. Okay. So this is enough. So this is a default overridable bit. Is default it is 1. So if it is 1 means you can able to override this 10,000 with this 9,200. So by this you can able to override the default set timeout. And how to write the UVM phases that we will see here. In this example, we just take a build phase. Okay. So class agent extends UVM component. So this is used to register this agent to a factory. So inside the agent, inside the agent, we have monitor, sequencer, and driver. Okay. So I instantiated sequencer, driver, and monitor. This is the handle for this. Then this is a new constructor used to build this agent. Then here virtual function void build phase, then bracket UVM phase. Okay. So this the build phase I am replacing. Okay. So inside the build phase, I am create a handle. I am using create method. I am create an object for this sequencer. This handle sequencer equal to sequencer, that is name of the class. Okay, which is already registered to the factory. So our type ID will be created for that, and using create method I create an object. So this creation should be happen in the build phase. Okay. In early example we saw, right, TLM. So that connection we made it in connect phase. This similar way we have the different phases. Based on the operation, we have to use the phases. So it is good practice to write a virtual before each function. You have to mention virtual. The reason is when you inherit this class agent, okay, another agent you are inheriting. My agent extends from agent. Okay. So there if you write a build phase, okay, when you want to override your base method with the derived method, okay, if you mention which one, then only you can able to override your base class, your derived class method by the base class. Okay, you can able to override your base class by the derived class. Okay, if you didn't mention the which one, you can't able to override this one. So it is to practice to write virtual for all the functions. Then here we are passing the argument as a phase, right? So UVM phase is a UVM phase. So it is argument you should pass. It is helpful to make synchronizations. Okay. So in each phase, basically this build phase is inherited from UVM top-down phase. So it is extended from UVM phase. So if we pass this phase, so automatically this argument will be passed to the top level classes. So that will be helpful for synchronization, and also this phase you can able to create objections that we will see in next slide. So mainly the need for passing the phase is for synchronization purpose. Internally it will take care of the synchronization. So phase synchronization, that means this is a run phase, whole thing is a run phase. So actually we are creating a run phase in three components, component 1, 2, 3. Okay. So I already told run phase has the subphases reset, configure, main and shutdown. So if component 1 reset happens at a small time, so component 2, 3 takes some more time, and component 2 will take more time. So once the maximum time of reset completes, then it move to the next phase, subphase of configure. So until that, it will wait and it move to the next phase. You see, configure phase happens of these three components. Once the lengthy configuration phase, maximum time taken by the component 3, when this configuration finishes, then it move to the main phases. So all phases are synchronized internally. When all the main phase completes, then it move to the shutdown phase. Then once all the shutdown phase ends, the maximum shutdown phase ends, it will move to the next phase, that is the extract phase. Objections. So in each component can rise and drop objections. Okay. So I will show the example in the next slide how to rise and drop the objection. A component that rise objection remains in the same phase until all the objections are raised. Okay. So usually we will raise the objection in the run phase. Once you raise the objection, until the objection is dropped, it will be in the same phase. So this is the way we have to raise the objection. Phase within the run task, phase dot raise objection. In bracket, you have to pass this. Here I am raising the objection in this class. So actual process we have to mention, and then after completing that we have to mention phase dot drop objection this. So this rise objection and drop objection in this class, if you see the rise objection method, so it has this argument. Okay. So string description, if you want you can pass it. Okay. So if you want to display this string description you are mentioning, okay. So that if you want to display that, you have to use this plus UVM objection trace. In the inline command, if you use this in the log file or transcript, you will get the display whatever you are mentioning or you are passing through. So this is mapped to UVM object. Default value is null. If you pass this is assigned here. And string description and this int count is optional. So if you want to pass any string description, you can mention here. Then int count. So this count value is default value is 1. Okay. So when you raise objection, assume that I have 3 run phases. Okay. in each run phases I am raising the objection. So in first run phase, if I raise the objection, the count value will be 1. Then next objection, next run phase, in second component, if I raise the objection, the count value become 2. In third component, in run phase, if I raise the objection, the count will be 3. Okay. So in the first objection, in the first component, in run phase, if I drop the objection, in drop objection count will be increased 1. Okay. So then second phase, if I drop, it will increase 1. Third phase, if I drop, it increase 3. When rise and drop objection is say, then it come out from this run phase. Okay. So until that, it will be remains in the run phase. It will not come out from the run phase. Okay. So how default time, which we mentioned, right, 9200, until that it will be in that run phase. If the default time expires, then it come out from the run phase. So this is one example for objections. So here in class agent, extend from UVM agent. So in this run task run phase. Okay. So UVM phase here this phase dot raise objection. This here I am doing some process for 100 nanoseconds, and I am dropping the objections and end of this run phase. Here this is another component driver. It is extend from UVM driver inside the run phase. Okay. So this run phase should be a task, not a function, because it's a time consuming one. So you should write the run phase in the task. So task run phase, UVM phase. So inside this driver, I am writing the objections, and after 10 nanoseconds, I am dropping the objection. So here, when it will come out from this run phase, once all the objections are dropped, then it will come out from the run phase, then it will move to the extract phase. Okay. Yes, it will rise the objection, and after 10 it will drop the objection. So this rise objection become 1, this drop objection become 1. Okay. So here actually this rise here 2 rise objections are. So here we raise one objection, here we raise one objection. So total rise objections are 2. Here I dropped one objection, so it is 1. So once this 100 nanoseconds complete, again we are dropping the objection. So drop objections also become 2. So rise and drop objections are equal. So it come out from the actual run phase. Okay. Then it move to the next phase. So until that it will be remains in the same phase. Okay. Messaging and reporting mechanism that we will discuss tomorrow.